Today's lesson is on experimental probability. So by the end of the lesson, you're going to be able to determine the experimental probability of an event. And when we think about experimental probability, we use one of our root words in here, the experiment. Okay? Very important word. We're actually performing an experiment. How many times something happens out of the total number of trials. Okay? So your experimental probability will not be the same as your theoretical probability. So our first example for this is shooting baskets. So if Hank shoots a basket 20 times during practice and he made 15 of the shots he took, what is the experimental probability that he will make his next shot? We can come up with our answer by thinking about what is the ratio of number of occurrences, or favorable occurrences we could say, or shots made, versus the total number of trials or the total number of shots taken. Okay. So how many shots did he take, or did he make? We have 15. Then we think about how many shots did he take. He took 20. So what is the probability he would make his next shot? Nothing's guaranteed, but if we know he did 15 out of 20 before, we can give a fraction of 15 out of 20, and that actually gets simplified down to 3 out of 4. If we turn it to a decimal, 3 divided by 4 is 0.75, and if we turn it to a percent, we get 75%, and we do that by multiplying by 100. So he has a 75% chance of making the next shot. If Hank decides to shoot 30 more times, how many shots is he expected to make? So our question is, what is the percent of shots? What is 75%? Because that is the percentage of shots we know he makes of 30 shots. Okay. And so what operation will we use to solve this problem? We're going to go ahead and use multiplication. Okay. That of lets us know we're going to multiply. We're trying to get 75% of. We're multiplying 75% by 30 shots. So if our answer in a completed sentence, we're going to do 75% times 30, which is also the same as 0.75 times 30. Okay. And the answer to that, we actually get 22.5. Okay. And obviously you cannot make a half of a shot, so we would probably round this up to 23. He's going to make 23 out of the possible 30 shots. The other way you can go ahead and solve this if you wanted to, you could actually create a proportion for it too. So to go ahead and do that, we know that he did 15 out of 20. And if we create a proportion, we would say the total number of shots is 30 versus 20, and then we put our variable up here. And if we go ahead and solve that, 30 times 15 is 450, equals to 20x, divided by 20. And I still get an answer of x equals 22.5, which rounds to 23. So that's the other option to solve them. Alright, example number 2, rolling a die. Julius rolled a 6-sided die and recorded the results in the table. What is the experimental probability that he rolled a 5? So let's first go ahead and look at our table here. We have the numbers on the cube. Normal dice have 1, 2, 3, 4, 5, and 6. So 6 sides. Our frequency is how many times it gets rolled. So a 1 was rolled 8 times, a 2 was rolled 3 times, a 3 was rolled 9 times, a 4 was rolled 6 times, a 5 4 times, and a 6 6 times. Okay. So how many occurrences came up with a 5? If we look at a 5 here, we get 4 times. And then we talk about how many total trials there are. To figure out how many total trials there are, we have to figure out how many total times it was rolled. So we have to add all of this up. So 8 plus 3 is 11, plus 9 is 20, 26, 30, 36 times. So how did you get this number? We can say add all of the trials, / frequency. Okay. We can say, what is the experimental probability he rolled a 5? So as a fraction, we would say 4 out of 36, which is actually simplified to 1/9. And we can turn that into a decimal by doing 1 divided by 9. And we get an answer of 0.1 repeating itself. And if we turn that into a percent, it turns out to be, we're multiplying by 100, 11.1% repeating. So we have an 11% chance of rolling a 5. We go on to our next question here. It says, if Julius decides to roll the die 18 more times, how many times would he expect to land on a 5? So we have to take our percentage, our fraction from before. So we would say, what is, and I'm going to use the fraction because it's not the repeating decimal, so it's going to be a little easier. What is 1/9 of 18? Okay. And so again, I'm going to use multiplication, okay, to go ahead and solve it. So I'm going to go ahead and do 1/9 times 18, which is actually equal to, if we multiply across, we get 18 over 9, which is equal to 2. If I wanted to solve it with a proportion, I can go ahead and say he averaged 1 out of every 9 times, which is proportional to my 18 total times. Okay. Cross multiply, and I get 18 equals 9x. Divide by 9, and I get an answer of x equals 2. So same answer. So if he rolled it 18 more times, he would get the 5 twice. Alright, so what I'd like to go ahead and do is pause the video. Go ahead and try these 3 problems right here. Once you've tried the 3 problems, you may go ahead and start the video back up again, and let's see how you did. Alright, so number 1, we have find the experimental probability of each event. You're going to write it as a fraction, decimal, and percent. So if a car factory checks 360 cars and 8 of them have defects, what is the probability the next check will have a defect? So I go ahead and figure out my probability or percentage of cars that have defects to be a 8 over 360. 8 cars have defects over 360 total checked. Simplify it to 1 over 45. Turn it to a decimal, 0.02 repeating. Turns out to be 2.2% repeating. So 2% of the cars on average have a defect. Number 2, in 10 frames of bowling, Hillary was able to get 3 strikes. What is the experimental probability that she will not get a strike if she bowls 20 more times? So we have strikes per total frames, 3 out of 10. She has a 30% chance of getting a strike. But notice how the question says, what is the probability she will not get a strike if she bowls 20 more times? So if she does get a strike 30% of the time, that means she doesn't get a strike 70% of the time. And so if I go ahead and solve my problem for 20 more times, I'm going to go ahead and do 20 times my 70%. So what is 70% of, I'll do 70% of 20. And I can multiply 20 times 0.7, and it equals 14 times. So out of those 20 times, 14 of them she wouldn't get a strike, which means 6 she would get a strike. Alright, number 3. You plant 30 African violet seeds and 9 of them sprout. Should be. Use experimental probability to predict how many seeds will sprout if you plant 20 seeds. Okay. We have number of sprouts divided by number of seeds. We have 9 over 30, which gets simplified to 3 over 10, or a 30% chance. So I'm going to go ahead and take my 30% chance, and I'm going to go ahead and solve by 2 ways. One is I can use a proportion. I can do 3 over 10 is equal to blank over 20. And I get that because 20 is my new number of seeds planted. I simplified it before to 10 seeds planted. And so I can use a proportion to get 6 seeds will sprout. And the next one I can do is solving with a number sentence. I can do 30% of 20. So 30% times 20, 0.3 times 20 is equal to 6. I get my same answer.